Hello, Year 11. Welcome back to another video. We're going to be looking today at energy expenditure. So last lesson, we looked at nutrition and the energy that we gain from eating different kinds of foods. Today, we're looking at how your body expends that energy and at different rates. We're going to be looking at different ways that we can estimate and calculate that. Now, what's important here is we don't want to get too hung up on the details of all the individual calculations. What's important is that we can just use the information that's provided to us. That is the information that might be in a table or a particular equation that we might be asked to use. So basically, this is a skills-based thing. You don't need to remember the specifics, but you need to remember how to read the information and then calculate by reading the question. So this first example, we're given a table of different activities and different rates of energy that are involved in these different activities. We can see here, so things like walking use less energy as running, for example. So all we need to be able to do is be able to read the table and then do the calculations with the information we're given. So for this part A, we have a 60 kilogram girl walking for 30 minutes. Now, if you notice, this is what we need to be able to do, is notice the information and the form that's given. We've got kilojoules per kilogram per 30 minutes. Okay, so the amount of kilojoules in 30 minutes is going to be 8.1 for walking. And then it's 60 kilograms. So that means we have to multiply this by 60 because this is per 1 kilogram. So we've got 60 of them. And then it's per 30 minutes. So because we're doing it for 30 minutes, we don't need to change it. We can just multiply it by 1 and we'll get our answer there. So we pop that in our calculator and we get 8.1 times 60. 486. And then for part B, we're doing aerobics, so it's 10.8 from the table. We've got 65 kilos, but this time we're doing it for 50 minutes. Now, if we want to work out what we need to multiply this by, we've essentially got a fraction here. So it's 50 minutes, okay, per 30 minutes. So it's 50 divided by 30 here is what we're going to multiply it by to incorporate that. So we get our calculator up again, and it's going to be 10.8 times 65 times 50 over 30. And that gives us an answer of 1170. I should say kilojoules as my units. And then for C here, a 70 kilogram boy plays basketball. So you get the idea. Just quickly show you the calculation. So we're playing basketball, 2.3. Whether or not they're a girl and a boy doesn't matter in this. There's nothing to tell us that that would be different for these particular method of calculation. So we would just do this, pop that in our calculator, and that will give us our answer. So that's the method used. So we just read from the table, worked out what the units were, and then applied the information that we were given to calculate what we needed to. Now, these next questions are going to use this concept of basal metabolic rate, or BMR. And what that is basically just the sort of basic amount of energy needed to sustain your body. So without even doing anything, you could have your eyes closed, lying down, your body's still using energy just to keep your organs going and to keep you staying alive. Now, the amount of energy your body does can be calculated in different ways. So we're going to be looking at two particular ways that we can calculate that. And they both involve different factors. Some of them are simpler to calculate. Some of them require more factors to do and might give you a more accurate estimation because of that. So this is the Schofield formula. So none of these are right or wrong in terms of the way to calculate it. They're just different ways of estimating. Some are easy and some are So this Schofield formula uses the gender. So it incorporates the gender. It incorporates the age, and it also incorporates the weight of the individual when calculating the BMR. So for part A, we've got a 17-year-old female. So what we need to do is go to the 11 to 18 bracket in our table, and it's a female. So we're going to use this formula here, and it's going to be 56 times their weight, which is 58 kilos, and then we plus 2898. Okay, so let's get our calculator up. 56 times 58 plus 2898. Press equals, and we get 6,148. 46, sorry. But you can see there, we're just using the formula given in the correct cell of the table. For part B, a 35-year-old man, that's going to be in this 31 to 60 bracket. We're going to use the male formula, so 48 times 35. Sorry, my mistake. Shouldn't times it by their age. We should times it by their weight, which is 92. So it's 48 times their weight, which is 92, and then plus 3653. And that gives us basically the amount of energy needed to keep that particular person going each day. Okay, so this is for one day, requires this much energy. And this is per day. That's what basal metabolic rate measures. So if you didn't consume enough energy, you would use your body supplies of energy stored in your fat. Eventually, you would run out of energy. All right, let's look at a different way of calculating BMR. This is the Harris-Benedict formula. Now, what this formula is, it again counts for the gender, females and males. It uses the weight of the individual, the height, and their age as well. So the difference between this, the last one and this one, is that it incorporates the height as well. And it actually changes year to year as well. So it uses the age, but rather than having brackets, it uses the specific age when we're calculating it. So all we need to do is use the information in the question and use the formula that we're given. Again, you don't need to memorize this formula. You just need to use the information that you're given. So for part A, we've got a 17-year-old boy. So we're going to use the male formula. He weighs 82 kilos and his height is 178 centimeters. So it's going to be 278, okay, plus 57.5 times their weight, which is 82, plus 20.9 times their height in centimeters, which is 178, and then minus 28.2 times their age in years. Now you might be wondering, where did these numbers come from? It's not so important. This would have been, done by trial and error to try and work out what sort of model roughly predicts what would have been measured. So I imagine the way they would have gone about this is they would have just measured the basal metabolic rate of different people and then tried to come up with some sort of formula that matched the data that they measured. But we don't need to worry about that. We just need to use the formula, pop it in our calculator, and we get the BMR. So kilojoules per day. I write that down? Yes, correct. Okay, and so for this last one here, we have a 16-year-old girl. So we're going to use the top formula. So it's going to be 2783 plus 40 times her weight plus 7.7 times her height, and then minus 19.6 times her years, which is 16. Pop this up, 273. Okay, so there's slightly different weighting adjusted to each of the factors between males and females. Again, this would have just matched the data that they would have measured. when they were coming up with this model. So 19.6 times 16. You just got to make sure you popped it in your calculator correct. Okay, and what you'll notice is generally for males with large body weights, it's going to cost you more energy, basically because you've got more body mass to keep alive. So your basal, the amount of energy that you consume just by resting is going to be higher the bigger you are. Okay, so that's basically what we need to do when we're calculating the energy of just resting. Next lesson, we're going to look at more detailed ways of calculating the energy of doing activities. Good luck with the questions.